Hey everyone, I'm Kabur Kwasa. I'm with Ismail. We're going to present. Okay. So our project is about dental disease detection in Uganda, right? So here we're looking at large vision models like YOLO, dentistry, video embeddings, dental diseases detection, localization, expandable AI, and resource screening. So this solution is meant for mostly general practitioners and patients. For patients, they can get about their general health. They can get to know that, okay, I have this disease, so I should start maybe flossing more, brushing more, and all that. So for practitioners, they get to close up that knowledge gap in terms of dental health. So now they don't need to go and look for ChatGPT or something like that. They have a solution on their mobile phone where they can just take a picture and then it gives them more a clear understanding and more information about the certain disease. So here is a table of content, introduction, the work, problem statement, so oral diseases. So here, introduction is oral diseases among the most prevalent, like non-communicable diseases. People don't really take care of them. So here we're doing a project that's going to bring information closer to the end users, that's the general practitioners and patients. So here we aim to give them an AI solution that can detect diseases just by taking a picture on the phone, and then it brings the diagnostic capabilities closer to the users. And here we try to research about like related work. People have done something similar and found two really close literature research papers. One was deep learning application in dental caries detection using internal photos taken by smartphones, and the link is there. Here they use CNNs, and then it was detecting dental caries, but in here they used an X-ray data set. And then the second one was prompting vision language models to be aware of the abnormalities. So here they use large vision models to clip to get to annotate, like label different teeth. Like this one has caries, this one maybe has conjunctivitis. Okay, all those diseases. So now the problem statement is, I'm on slide 5. The problem statement is oral diseases are usually underlooked, and then they are becoming something that's going to be an issue in the future when people don't know how to take care of themselves. Like you have seen lately, people don't have white teeth. People have primary input is going to be a real-time image captured from a smartphone. But for training data, you're going to use an oral disease data set, not X-ray, a normal picture. And then the outputs are going to be rectangular boxes drawn on the video feeds directly. And then our objective is to have a mean accuracy precision of over 8.85, measuring overall detection accuracy over the whole video. So the objectives, research objectives and questions: can the AI tool bring basic dental screening directly to our local communities? Okay, here the objectives of the research. We want to try to bring the AI closer to villages so that they don't have to travel back and forth in order to take care of their teeth. And also by identifying the caries earlier, someone doesn't have to go to extreme measures of removing the tooth and maybe buying a fake one. Yeah, it can just be sealed by using, okay, they seal them using that form. Then here health workers can give visual feedback to a patient. Now, like here, after taking a picture, instead of a doctor telling you, oh, you might have X, Y, Z, here they have proof like, okay, this is where the problem is, and here is how you can solve it using the video they got from your teeth. So it gives the patient more confidence in the doctor. And early stage treatment is very cheaper than severe treatment. So the output is we're going to use architecture, which is optimized for real-time and multi-class disease detection. So here we shall deploy we shall try to deploy first an online model which is over the cloud, accessed over a certain IP. And then here on the mobile phone, we just call on an endpoint, then the endpoint goes and then pushes to the cloud, and the cloud gives real-time prediction. But that, because of that whole cloud and it's going to be slow, so we shall try to reduce the model to a lighter version which can be deployed on a phone. So here is the general architecture. Here I just put in the video, the video into the model. The model is going to use yellow core to detect which disease and then to output boxes around the issue where the tooth has an issue. Let me say if it has caries, it will go around the yellow area and then give us the issue. Then there's a description. So with the data set, we used a data set from Cargo because we tried to look for image data sets that were not X-ray, that were free online. We found it hard, so we had to now go in for data for Cargo data sets, even though it's not allowed. Please forgive. So for the dental, it basically has the features. It has caries, caries, conjunctivitis, tooth discoloring, ulcers, and hypodensity. Those are the diseases, image diseases that we are having, so that the images are put in folders where those diseases belong, and then they are fully with full annotation and argumentation. So basically, here we're going to use supervised learning fully because everything has been labeled. Next slide. So now I'm going to call in Ismail to take on to the next part.
These are the classes. These are the images we got. We divided them into 3 classes. We had the training, the validation, and the testing data. So these ones are the different cases for tooth cases like calculus, then caries, and others. And these are the images for each class we had. Like, for example, the first class we had 991 for training, then for validation 175, then for tests 130. Then this is the data visualized in a pie chart format to show like the data we had for the different classes and the percentage of the data we had, the training images. And this one, it is also displaying the images we had. The blue is for the training, and the orange is for validation, and the green is for the test. So you can see we had a lot of data for the training, and more data for the validation than the data for the tests. Let's look at some sample images that were in each class for the diseases, tooth diseases that we got. You can see these are some images like for the calculus. This is the row for calculus. Then there is this other case, hypodementia. These are the images and many others there. So let's talk about the model details. As my colleague had already said, we are going to use a lightweight YOLO model. It's called a YOLO is a model that looks at the image only at once, unlike other models that look at the image consecutively, like more times. So the YOLO looks at the image once and then classifies that image. Then for the demonstration, we shall deploy this model to mobile devices and cameras and smartphones, though we haven't deployed this model to these devices. Then the conclusions, we were able to develop the lightweight model. We trained it and we tested it. And here are some limitations that we trained it basing on the cargo images, but not actually Ugandan images. So it may perform differently when it may come to Uganda, when it handles Ugandan images. Then we have not tested on the actual cameras, like the real cameras, like implementing it on the cameras. We were able to train this model on the images and what images we had, though we have not implemented it in the real device. Then It is also limited to those cases, the classes we that we had. Though we know in dentistry there are other classes or issues that may be available. Then it is also based on visual symptoms. So things like when did this start? How has it been how has it been treating you? Is it aching or what? This model doesn't do that. It basically looks at the current visual appearance of the tooth or the mouth to give you the classification. Then in our future steps, what we are going to do next, we shall focus on building the mobile app, then deploying it to the internet, also deploying it onto the mobile devices and cameras in case we get one. So that's all for our presentation. Thank you. In case I have left anything, Conrad, you can add on.
I guess that's all. That's it for now. As you're going to submit, you'll find the Jupyter notebook and this presentation. Thank you for listening. I guess it's done. You can now continue.